All right, this is what we're doing today on Thursday, December the 10th. I'm putting together a quick little quiz for tomorrow, or kind of like a half test, because we have students that would like additional opportunities to improve their grade. And so this is the exact kind of questions that'll be on it. So here's the equations we've learned. Second law, which says that there is a net force, there is going to be an acceleration based, and it is inversely proportional to its mass. And the definition of force of gravity, weight, and force normal. I'm sorry, definition of force of gravity, which is equal to its weight, which is equal to mg. And so here is some practice problems. So if you could do this, you should do well on this, and maybe it's an opportunity to raise your grade if you're right on the edge. So if a student weighs 500 newtons on Earth, so this is all on Earth, and weighs 4,500 newtons on planet X, what is the acceleration due to gravity on that planet? So we know that weight is equal to its mass times acceleration. This is on Earth. So we know the weight on Earth, and we know the acceleration due to gravity on Earth. And so we have to find mass. So mass is equal to its weight divided by g, which is 500 newtons divided by 9.8 meters per second squared, which is equal to 51 kilograms. And what we're trying to find is g on that planet. So weight is equal to its mass times g on that planet. So g is its weight divided by its mass, which we found from the information on Earth. And on the planet, it was 400 newtons divided by 9.8 by its mass, which is 51 kilograms. And that is equal to 88.23. And that is in meters per second squared. What is the mass of an object that experiences a gravitational force of 459 newtons on Earth? We want to know the mass. So Fg, which is equal to mg. So mass is equal to Fg divided by g on Earth. So we take 459 newtons and we divide it by 9.8 meters per second squared. And that equals 46.8 kilograms. A 71 kilogram parent and a 29 kilogram child meet in the center of an ice rink. Here they are. And they push each other. They place their hands and push. If the acceleration of the child, well, here's the child, here's the parent, and this mass is 71 kilograms, and this mass is 29 kilograms. They place their hands together and push. The acceleration of the child, so this child's going to have an acceleration of 2.6 meters per second squared. What is the magnitude of this acceleration? Well, if you recall, there's a force from the parent on the child, and there's a force from the child on the parent, and those are equal in magnitude, opposite in direction. And so we're going to focus on the side that we know the most information on, which is the child. And we have an acceleration and a mass. So we know that the force, the net force, which is only one force, they're on an ice rink, I think. Yep, no friction, is equal to its mass times acceleration. So if I need to find this force so that I can come over here and calculate its acceleration. So that force is equal to 29 kilograms multiplied by 2.6 meters per second squared. And that is equal to 62.4 newtons. And then If I use 62.4 newtons over here, I have, we want this acceleration. So we know the net force is equal to mass times acceleration. So acceleration is equal to F net divided by mass. And that will be equal to a negative 62.4 newtons, because I'm to the left, divided by the parent's mass. And acceleration will equal negative, oh, meters per second squared, negative 0.88 meters per second squared. All right, if I have a net force of 225 newtons and it's applied to an object, here's my object, and here's their acceleration, 23.3 meters per second squared. What's the mass of the object? Well, we know the net force is equal to mass times acceleration, so mass is equal to force net divided by acceleration, which is equal to 225 newtons divided by 23.3 meters per second squared. Which will give me 9.7 kilograms. Person steps on a scale in an elevator. So they're inside the elevator. What does a scale read when it is traveling with a constant velocity? What does that mean? That means zero acceleration. Okay, A. Force equals ma, the sum of all the forces. Well, let's draw a free body diagram. When it's standing on the scale, we have force normal up, we have force of gravity pulling down. This is what the scale reads. So we need to find force normal. So the sum of all the forces in that situation is force normal minus Fg, and this becomes 0. So force normal equals Fg, and Fg equation is mg, which we know, which is 45 kilograms. Unless they tell you we're on Earth, unless they tell you something different, you have to assume you're on Earth. 45 divided by 9.8. I'm sorry, not divided by. Multiplied by 9.8 equals 441. So force normal equals 441 newtons. So this is the answer to A. B. Now the scale reads 510 newtons, which becomes our force normal. And we want to know what the magnitude is of the acceleration. Okay, well, we'll draw a free body diagram again. It looks exactly the same. And we sum the forces. Net force equals its mass times acceleration. So what's the net force? It's force normal minus Fg equals mass times acceleration. So they're telling me I have acceleration. So I can't cross this out. And that's actually what I need to find. Okay. They are, so I have to get acceleration by itself. So force normal minus Fg divided by mass equals A, and I have all those numbers. So 510 minus Fg, which is its mass, which was 45 times 9.8 divided by its mass, and that will equal acceleration. So let's do that. I find acceleration to be 1.5 meters per second squared equals A. This is a positive number. It would have came out negative if it was down, so this is up. It is accelerating upwards. Oh, that was the answer to C. Okay, so if you feel like you understand how to do that, you should have an opportunity to increase your grade, especially if you're right on the bubble.